All right. Hello and welcome. So it is time for us to officially prepare for your AP Physics 1 exam. So we should be in really, really good shape based off of the effort that you've been putting in for your unit tests and the results that we have been getting, especially after Unit 8. We crushed that one. So we are in position with 2 weeks of good studying to really put ourselves into some nice fours and fives. So, for the actual AP exam, there are two sections. The first section is your multiple choice questions section. There will be 40 multiple choice questions. Each one of them has a single answer, and in total, that gives you 40 points, 1 point per question. You have 80 minutes for that section, so that averages 2 minutes per question, and that accounts for half of your total score. Then the free response section has 4 questions. There is one question about experimental design that's worth 10 points, one question about qualitative quantitative translation, which is worth 8 points, one question about mathematical routines, which is worth 10 points, and one question about translation between representations, which is worth 12 points. We'll go into detail on all of those. That entire section takes 100 minutes and is worth half of your total score. So you can see there's 40 points on the MCQ side and 40 points on the free response side. So it's a 50-50, even though you have a little bit more time on the free response. That averages out to about 25 minutes per question, but you can use 30 minutes on one question, like the translation between representations, because it has a couple extra points, and use, say, like 5 less minutes on a different one. Okay, so the good news is in our class, we have been scoring everything on the AP scale, and we have been setting a 5 at 85%, a 4 at 70%, a 3 at 55%, a 2 at 35%, etc. Now, for the actual AP exam, the historical trend on where we set the bar in terms of what percentage of questions you have to get correct in order to earn a certain score. 70% will get you a 5. So you just have to get 7 out of 10 of the points and you're at the 5 level. That would be, if you've been getting 4s on our tests, you might be able to get the 5 on the AP. 54% is where the 4 starts, and 40% correct can get you a 3, historically. I can't guarantee that that number will be exactly precise. It might be 42% or 41% or 39, but that's our passing line, right? That's where you need to be in order to pass and get credit for that AP exam. So the good news is that there is a much lower bar. The bad news is that it encompasses all of the units. So you have to do a lot more thinking about which unit this question comes from and which way you want to go about solving it. And then you also have to really think about time. I have been much more generous with time and allowing us to take the 10 extra minutes to finish things up. And there is no extra time on the real AP. So, big things to consider. Timing. It is time right now to start running an AP practice test with a timer attached to it. So run one of the AP MCQ sections and put an 80-minute timer on, and that's how long you have. If you're going beyond that 80 minutes, you won't be able to finish those final questions. The other thing to consider is that you will be taking the test through the AP Bluebook app. Make sure that that AP Bluebook app is downloaded onto your Chromebook and that you can open it and get in. We've been doing all of our tests through AP Classroom, and this is a slightly different platform, although it should read exactly like AP Classroom. You just get into it a slightly different way, and it locks out all of your other browsers. The reference sheet. We've been using a paper reference sheet, and you will not be allowed to bring in a paper reference sheet or have one given to you. So the reference sheet will be the drop-down menu where you click on the upper corner where it has like a little X squared. And that will give you all of your equations. So start getting used to it now in the Bluebook app and making sure that you know where to find all of your fundamental equations. And a calculator. You can bring in your own calculator. I strongly recommend that you charge up your calculator Make sure that it is ready to go and bring it with you because that's the one that you're used to using. If you don't bring in a calculator, there is one embedded into the Blue Book app, but it might be a little bit clunky if you're not used to using it. So I would have your own separate calculator ready to go. And obviously, bring pencils and pens so that you can do your scratch work, and you will have to handwrite your answers for the FRQ section. So you will read the questions off of the computer in the Blue Book app, and then you'll answer them by hand in the on paper. So that's so you can do free body diagrams and graphing and derivations without having to worry about weird typing. In terms of content, this is the exam weighting by section. So kinematics ends up being about 12%, forces 20%, energy 20%, momentum 12%, torque 12%, energy and momentum of rotating systems 6%, oscillations and harmonic motion 6%, and fluid 12%. So you can see that 40% of the test is skewed around force and energy. And I would argue even more of it is around energy because you've also got that 6% of energy of rotating systems. And you could push in some energy with oscillations and with fluids. So there's going to be a lot of energy in there, a lot of forces, and a lot of momentum, which brings us to your multiple choice section. So if the question is really obvious that it comes from a certain unit, like if it's about torque, use torque. If it's about fluids, use your fluids equations. However, if you get into a question and you're like, I'm not totally sure how to attack this one, our order of operations, if you get stuck, should be try addressing it with conservation of energy first. The chances are that it's going to be a conservation of energy equation first, because there's more of those questions on the test. Then I would try to address it with momentum. Technically, there's more force questions than momentum questions, but for the ones that we're not totally sure about, they might be momentum questions, and it's worth taking a look and seeing if you can do it with momentum. Then I would go into forces and see, can I draw a free body diagram for this one? Can I solve this by using Newton's second law and doing a sum of the forces and a net force? And then finally, I would default to kinematics. That would be my last choice because kinematics is going to be a little bit trickier and take a little bit longer. And there are going to be fewer of those kinematics questions. On the multiple choice section, there will definitely be some graphing questions. The graphing could be from any content area, and you'll be given some graphs. There are a few ways that you could potentially analyze those graphs. The first way would be looking for the slope. So look at the two axes, velocity and time in this case, and see what happens if I divide them. If I divide the two axes, I can get acceleration. Is the question asking for acceleration? Great, take a slope. The other option would be to take the area under the curve. To find the area under the curve, I want to multiply my two axes and see what that gives me. In this case, it would give me position or distance traveled. And then my last option would be to read the graph directly. So for example, the maximum speed shown here is 5 meters per second. Obviously, this doesn't just have to be for kinematics. It's not just for velocity. I could use this for any content area. For example, if it was talking about impulse or momentum, I might be asked for the change of momentum and given a force versus time graph. And in order to find the force versus time, I need to find the area under that curve. Just as a reminder, when finding the area under the curve, break it into sections. So I would break this into a triangle and a rectangle, and then I would find the area of the triangle using 1/2 base times height, and then the area of the rectangle using height times width, or length times width, whatever you want to call it, side by side. Okay? And then add those together, and that'll give you your total sum under the graph. The other key piece is timing. We have been taking a long time on some of our questions, which is good. I want you to think through them. But now we are really under a timing crunch. So for that timing crunch, you have 40 questions in 80 minutes. That means 2 minutes per question on average. If you get to a question that you recognize requires a derivation, and that derivation is going to be kind of lengthy, like it's going to take you longer than 2 minutes, it's probably worth putting in your best guess, flagging that question, and coming back at the end. Every question is worth 1 point, so you may as well get through all of the questions that you know you can get the answer to in the first, say, 60 minutes, and then coming back and taking longer time on the ones that are going to require more time. One tip off that it will take a long time is if there are weird fractions before your answers. So, like I gave an example here where it's like all of them are m sub s g v max over r squared. I just made that up. I don't know what it comes from. And then my options are 1/3 or 5/6 or 4/3. None of those are easy ones, like 1/2, where it's like, oh, yeah, 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 that could just be the default 2 pi that gets thrown in there. 5/6 is funky, 4/3 is funky. Like that means I'm going to have to do some adding and squaring and subtracting pieces. So it's probably going to take me some time. If I see one like this, that might be an immediate flag it, like put in my best guess, just click C, right? 4/3, that could be it. Flag it, and then come back at the very end. And then finally, just for every single question, I strongly recommend drawing diagrams for everything. They're going to use a whole lot of variables and a whole lot of descriptions. Try to draw out, like, okay, we have a box and the box has a panel on it. Draw the box, draw the panel. The panel has 20 centimeters by 30 centimeters. And then I know that the pressure inside is 76,000 pascals, and the pressure outside is 35,000 pascals. And it's asking me to find the force on the panel. Okay. So like just like drawing that thing, I've suddenly taken words and turned it into like, oh, I've got a pressure and I've got a space that's an area and I've got a force. This is going to be a pressure equals force over area equation. So draw the diagram first and then run all of your work on scratch paper. Even if it's just jotting down notes as you're reading the problem, worthwhile time. The sketching should take you like 20 seconds, and that's very valuable time for answering those questions. Okay, let's keep going. And we're going to get into the specific FRQ questions. So for the specific FRQ questions, I'm going to go through each type of question. We're going to talk about what you will expect to see, and then I'm going to show you on the key where all the points are located. So you will have a mathematical routines question. That's a 10-point question in the free response. Remember, for this one, you get a grand total of 100 minutes. So that's an average of 25 minutes per. Some of them might take you less, some of them might take you more. You will, again, want to keep track of time. 100 minutes is a long time, but it'll fly through. So again, open up those practice exams and try setting a 100-minute timer and running it through in 100 minutes. So for mathematical routines, you will be asked to take a derivation. You will be asked to calculate some numerical values. You'll be asked to make predictions about the scenario that's given, and then you'll be asked to use some kind of a representation. Maybe it's a free body diagram, maybe it's sketching a graph shape. So in terms of the key, where your points are going to be on this one. In part A, they will usually break part A into 3 parts, I, double I, and triple I. So your derivation, 1 point is for starting with the big idea. They will normally tell you, starting with Newton's second law, or starting with Newton's second law in rotational form, or starting with conservation of energy. Sometimes it'll just say using a fundamental idea from your equation sheet. So start with one of those big ideas. If it tells you to start with Newton's second law, there's a point for writing down F equals ma, or sum of F equals ma. 1 point there. 1 point for one of the intermediate steps in the derivation, and usually a point for substituting something in correctly. So for example, if it shows you that x is listed as L over 2 in the harmonic motion, then there'd be a point for subbing in L over 2 in the x piece for harmonic conservation of energy. So like 1/2 kx squared becomes 1/2 k times L over 2 squared. So those are your 3 points for the derivation. Then there will be another derivation. In that other derivation, there's a 2-point derivation. One is for starting with a correct fundamental equation, and one is for giving a correct final answer. You might have to use a piece from your first derivation to sub in. So if you take the answer from your first derivation and have to sub it into your second derivation, that is potentially valid. We don't know exactly which derivations you're going to be given, but there will be 2 of them in this question, grand total of 5 points. Then there will be some kind of graph or free body diagram. So for the graph, 1 point will be for giving a correct shape, and 1 point will be for giving the correct location, like start and stop, or maximum value, or something about the graph where it's like, yes, that is the right shape. It should be concave up, and it should go from L over 2 to negative L over 2. Or if it's a free body diagram, 1 point for a correct force vector, 1 point for another correct force vector. And then part B is 3 points. Part B will ask you to make a prediction, usually in terms of comparing something to another scenario. So if this changed, then what would happen? So you'll have 1 point for making the correct prediction, like time of scenario A will be greater than time of scenario B. 1 point for explaining why using your first big idea. So like spring constant is a constant, so it doesn't change. You're referencing back to some big physics idea. And then the third point will be for explaining why with some kind of second big physics idea. So mass is proportional to period, or the square root of mass is proportional to period. So as mass increases, the time will also increase. The key piece on these ones are to explain your assumptions and explain your logic. So you might have to say, I know that there is more net force in scenario A, and because there's more net force, there must be more acceleration. And if something is accelerating greater, it will have a greater final velocity, which means its time will be less, right? Give it A to B to C to D. Explain all your steps. The second type of question that you will see is a translation between representations. This is a 12-point question, and it's kind of similar. Like you might not notice that it's a different type of question, and you don't have to, right? As long as you're answering them correctly, you don't have to be like, oh, that's the mathematical routines one. You'll be asked to make a visual representation. You'll be asked to make a derivation, to draw a graph, and then one of 3 options. So you'll either have to justify why your previous parts agree or don't agree, like does your visual representation agree with your derivation? Or you'll be asked to predict another situation. So what if instead of having this, then it was this? Or predict the changes if the scenario was changed. So they're giving you some kind of a scenario, and then you're representing it, and then it's saying, what if we gave you a slightly different scenario? What if the mass was different? In terms of the key and where the points are, this one is a 4-part question, A through D. In part A, it is usually going to be 3 points, and it's going to be about your visual representation or your graph. So this could be like a dot diagram or a motion diagram. It could be a graph, some way of representing the situation. They'll look for 3 points, and the 3 points are that 3 aspects of that are correct. Things that they could be looking for is the direction of the arrows right? Is the size of the bars on the bar graph correct? Are you starting at the right point? Are your values correct based off of what's given? Do you have this one bigger than the other one? So we're back. Apologies. So do you have those 3 parts? Are they right? The next part B, is a derivation again. On your derivation, it'll be a 4-point derivation. The first point, like the last derivation, is starting with one of the physics big ideas, like conservation of energy or conservation of momentum. Then there will be a point for correctly substituting in something. Maybe it's another equation, like I started with energy and then I have to sub in some kinematics parts or some force parts. Um, you have 1 point for correctly interpreting the diagram or the situation. So, for example, when the two blocks combine and stick together, their combined mass will be MA plus MB. And so instead of just including M, I represent that final mass as MA plus MB. And then 1 point for the correct final expression, the correct final answer for your derivation. Part C is graphing. And in your graph, they are looking for three correct elements of the graph. Possible places that could be correct: the shape of the graph, the value on the graph, some other value, the size of the bars or the line, that everything adds up correctly. Like my before graph is equal to my after graph if I'm conserving momentum. I have 4 momentum chunks on my momentum bar graph. I need that to match. And then part D is a 2 point question, and it's the justification. So you're going to explain how the graph matches or doesn't match your diagram and explain why using physics principles. So I would expect that the net force is going to be whatever. So 2 points there. This one, the part D, is your kind of tricky piece because that's 3 options: predict what would happen if the scenario changed, or justify why they do or do not agree. I'm thinking it'll probably be a why they do or do not agree. So explain why things match or don't match based off of what they've given you, right? I know that energy should be conserved, and in this diagram you've given me, energy is not shown to be conserved. So that does not match because conservation of energy says that everything should conserve before and after, assuming that there is no outside work done or no outside forces. Okay, we have two more types of questions. The first type of question is experimental design. So this one, you will be asked to design an experiment, and then you'll be given a similar experiment where data has been taken, and you'll be asked to analyze the data from that experiment. So for the design part, you'll be asked to develop a procedure, make sure it's scientifically sound, that there's one variable that you're changing, explain how you measure the things that you're measuring, and make sure that you have multiple trials. Then you're looking to analyze the data. So they're almost certainly going to ask you to analyze it using graph analysis, which is taking the slope of something. Or they could ask for a comparative analysis. And then for the next piece, part C and D is the analysis. So you'll be given some data. You'll be asked to make a detailed graph and then use the slope or the y-intercept to find some of the values. Remember to choose points on the line of best fit. Don't use the points that are directly given to you in the table. Make a line of best fit, choose 2 points on that line of best fit. So here is where the points are in that key. On the key, for designing your procedure is just 2 points. The 2 points are first to measure two relevant quantities using given tools. So for example, if you are given a pressure sensor and a meter stick, measure the depth of the water and the pressure at that depth using the pressure sensor. So that's 1 point. Usually this is going to be like pretty obvious based off of the tools that they give you. Don't overthink it. It doesn't need to be a 10-step procedure. You're just explaining what you're measuring with what tools. And then the second point is for reducing experimental error. The way to reduce experimental error is either to do multiple variations. So for example, measure the pressure at multiple different depths, or to do multiple trials. So each time measure 3 pressures at the same depths in different parts of the tank. Ideally, do both, right? So say run multiple variations at different depths, and then do multiple trials at each depth. Boom, check point for reducing experimental error. Part B is then going to say, once you've run that experiment, how will you analyze the data to find the thing that you're looking for? The answer is usually graph the two quantities that you measured explain what your y-axis should be and what your x-axis should be. So put pressure on the y-axis, put depth on the x-axis, and then explain what the slope will be. The slope will be density of the liquid times gravity, um, or what the y-intercept would be. The y-intercept would be atmospheric pressure. It'll tell you what you're trying to solve for. So like design an experiment to find the density of a liquid, given a pressure sensor and a meter stick. And you're starting by looking for one of your root equations that has density, pressure, and height or depth, and then figuring out the experiment that can get you there. Then the analysis, they're going to give you a whole bunch of data. Um, you are then going to use the equation that they give you. So they're going to say students derived an equation that is correct for something. Then you'll take that equation and set it equal to y equals mx plus b so that you can figure out what two axes you need in order to get a slope. So I did an example on this one. Let's say I was doing something with escape velocity, and students have correctly determined that the equation for escape velocity is root 2gm over r. I'm going to take my escape velocity equation, and it tells me you need to have v squared on your vertical axis. So then what should you put on your horizontal axis in order to make a graph that can give you a value for the radius of the planet? Um, so if you're trying to solve for radius of the planet, what do you need to have here? So I set my equation and then I squared both sides so that I have v squared on one side. Then I put y equals mx plus b above it and circled the parts that match. So y is going to be v escape squared. X is going to be m, the mass. And then the slope, which is also an m, but the slope is going to be 2g over r. And then plus b, there is plus nothing in this equation, so that's just a 0. That means it should go through 0, 0. So my y-axis will be escape velocity squared. My x-axis will be the mass. And then the slope should be equal to 2g over r. Then 1 point will be to select axes that give a slope that is asked for. In this case, the asked for thing was the radius of the planet. The second point will be to label and number the axes evenly and use most of the grid. Sorry, I have some words that got scrambled there. The third point is plotting the points correctly. And then the fourth point is an accurate line of best fit. That's going to be a straight line that goes through most of the points and traces the right, has an equal number above and below. So when I did this, here's part C. I was given the axes and the vertical axis. Make sure you label both of your axes and then evenly space the numbers on those axes. You'll probably have to do some calculation out of the data table because they won't give you v squared, they'll just give you v. So I would have to do my squaring of my velocities. So I did v squared in meters squared per second squared, and mass in kilograms. Include the units in parentheses, please. Then evenly number your values so that you include all of your data points. Write in what some of those data points are. So I put in 6 hash marks on each one and then labeled an even set on both sets. And so that's my first point is for getting my axes. Well, my first point is for choosing mass and v squared as my two axes. Check. My second point is for labeling my axes correctly and evenly spacing them. My third point is for correctly plotting all my data points. So those are my red dots. And then my fourth point is for putting in a line of best fit. I put in my blue line. It's a straight line that goes through all of my points and tries to have an even number above and below them. Then part D is a 2-point question. It'll ask you to calculate the slope using 2 points on your line of best fit. So basically, it'll tell you what is the like now solve for the radius of the planet. So you need to calculate the slope, use 2 points on the line of best fit. Do not use the actual data points given to you. Use the points on the line of best fit to find the slope. Then relate the slope to the requested value. So that will look like slope is change of y over change of x. I find 2 points on my line of best fit. I chose to directly do these ones because they lined up nicely. So there are my points that match the line of best fit. I've circled where those theoretical points are. Notice there's no red dot in those points. They are points on the line of best fit, and try to get them far away from each other so that you know that you have an accurate slope. Don't put the 2 points right next to each other because that's a very short line of best fit. Then take the change of y values, 100 million minus 20 million, divided by 1 times 10 to the 24th minus 5 times 10 to the 24th. These are gnarly scientific notation numbers because I happen to choose escape velocity because I'm a tiger for punishment. Solve for the slope. So the slope is 20 times 10 to the minus 18th. And then relate that back to the radius of the planet. I recognize that the slope was equal to 2g over r, and then solving for r, it should be 115 million, I think. 1.5 times 10 to the 7 meters. So 15 million meters. Okay. That is your experimental design one. And then one last FRQ question. And that last FRQ question is qualitative and quantitative translation. This is an 8-point question. You need to make and justify a claim about a scenario that's given, derive an equation, and then explain why your claim and your equation agree or don't agree. Or predict another scenario, or predict the change if something happens. You'll notice this is the same 3 things that we also saw in the translation between representations. So I'm guessing one of them will be explain why they agree or not, and the other one will be predict a different scenario. So on the key, this one is a 3-parter, A, B, C. Part A will have 3 points. It'll be a correct claim about what will happen in the scenario. The second point would be referencing a big content idea to explain your thought process. So conservation of energy, conservation of momentum, Newton's second or third law. And then add more detail that gets to the correct claim answer. So as the net force decreases, the acceleration decreases, and then the acceleration over the same distance leads to a greater time. Part B is 3 parts, and it's 3 points. Part B is your derivation. Like all your derivations, start with the correct fundamental principle or equation. If it tells you to start with one, start by writing out that equation. Even if it doesn't tell you to, start by writing out the big picture principle. Like U sub G equals K, conservation of energy, or sum of energy equals sum of energy. Energy is conserved. Then there's a correct substitution or a correct intermediate step. And then there's either another correct substitution or intermediate step or a correct final answer. But it's a 3-point derivation. And then finally, part C, it's a 2-point part that says match your claim to what happened. So the first part is a functional dependence of one variable on the other. So for example, the period is proportional to the square root of the mass in your derivation. And then the second point is for correctly linking your claim in A to your derivation in B. So like I said that the period will increase in my derivation, and in my derivation, I showed that the period is proportional to the square root of m, and that matches my claim. So in part A, I said blank. In the derivation in part B, it shows blank, the same thing. So it's just noting likely an inverse proportionality or a proportionality, direct proportionality, and then explaining why. Okay, So that is the AP Physics 1 exam. You are absolutely going to crush it. Best of luck. And now you need to go back and take a whole bunch of those practice questions. The more practice questions you take, the more you look at the key for those FRQs, the more familiar you will be with where those points are located. Good luck. You got this. Stop recording.